Ever felt like working with AI tools is like trying to fix a spaceship with a butter knife? APIs consistently change, integrations break overnight, and you're trying to start duct taping things together. Well, that's about to change, thanks to a game-changing standard called MCP. Hey everyone, my name is Khan and welcome to my channel, where we deep dive into cloud, AI, and everything about DevOps. Today, I'm going to explain Model Context Protocol, aka MCP, why it is a big deal, and show you a real example using the GitHub MCP server with GitHub Copilot Agents. If you're building the future of intelligent apps, you need to understand this. Let's jump into it. All right, let's start by looking at what is MCP and how it is architected. Okay, so MCP stands for Model Context Protocol, which means it is a way to connect AI models to external data sources and tools like databases or APIs. According to Zapier and Anthropic, it acts as a bridge, allowing AI assistants to not only access information, but also take actions based on it. Think of it as a standard way for AI to interact with outside of the world. Instead of calling the APIs of the tools like third-party tools, your MCP servers will handle all of the interactions for you. So you won't need to upgrade or maintain your API calls or your code, right? So as we define, it's a standard way for models, tools, and memory systems to communicate, which decouples LLMs from directly calling APIs, which models describe what they want and not how to do it. It also introduces structured actions, for example, search, summarizing, retrieving, instead of plain text prompts. MCP also uses clients, for example, third-party apps or front ends, and we have servers, MCP servers, which are basically tool backends that has the tools inside of the server itself, which communicates through MCP. It also allows multiple MCP servers, each serving different tools, to be connected easily. You can also do one MCP server and have a bunch of tools inside, like orchestration MCP server, but it's always good to segregate things out for flexibility, right? And it also supports multimodal inputs like text, images, tables, and memory in a structured and understandable format. It handles API changes gracefully. Tools are managed by servers, not the model. So let's say if I want to use Slack for automatic notifications, I need to interact with the Slack API, right? If Slack decided to update their APIs or change the structure of their APIs, I have to change my code to align with that change so my automation wouldn't be broken and continuous. But with the MCP, we don't have to deal with those. MCP server handles all of those API integrations and the changes. It aims to standardize and future-proof LLM interactions across different apps and platforms. So here you can see we do have this architecture diagram where your LLM model could be like your platform could be cloud, your ChatGPT, which is your MCP host, where you would have your client.python file that holds your MCP server info configuration, I would say. And you can see MCP is very similar to USB, where you basically plug it into your system that has the necessary tools, i.e. in this case, it might be Slack, Gmail, your calendar, which each of these are considered as MCP servers, or even your local data sources are your MCP servers that you plug all of them at once to your computer, I would say, your system, your LLM, right? So going further, now we understood the MCP, what the MCP is, but how it was working pre-MCP, i.e. function calling, right? Like what was happening before MCP. Here we do have the user, which basically queries a prompt and function declaration. For example, in my ChatGPT or a choice of my LLM, I go like, hey, what is the weather like in Toronto today, right? Or in San Francisco in this example. Then it basically takes that prompt, takes that query. My LLM has a function that calls, that requests a API call to the weather API to gather the current or whatever the weather ask was from the weather API, and gets the response from that API. Then it takes the API response, process it, maybe enriching it with some sort of other wrappers. Then it basically responds back as an output to me, right? So in this case, LLM basically works with the weather API in the background. But as we mentioned, if the application owner or the team decided to upgrade or change their API schema, what's happening is LLM side of things needs to update and align with that API call stuff, which is a lot of maintenance and management to do, right? So MCP is a solution for this, i.e., how MCP works is basically we have a user here that queries something like what's the weather in San Francisco. That basically my MCP client takes it, okay? My MCP client takes it here, and it basically have the tools, like the capabilities inside, i.e. my like bunch of different tools that you need. Then it basically takes the query, then from the query, it goes to the large language model. Then your large language model basically chooses the weather tool that's going to be using. It basically sends back to your MCP client, right? So after that, your MCP client is asking for approval, which your user needs to give approval for the API call, right? It's not gonna directly take the action. You need to do some sort of approvals. Once the MCP client gets the approval for taking the action, it's going to send the request to the MCP server, which is going to actually handle the API turns a handshake, I would say, right? It's gonna take the input, process it, and it's gonna give the output. Then what's gonna happen is it is going to it's going to give the data to the large language model, which large language model will be processed the data again for itself, and it's going to give the output to the user. As we can see, the temperature in San Francisco is 18 degrees Celsius, right? So what's happening here, bunch of different stuff, but what's good here is actually you don't have to manage, or you don't have to worry about API integration or API maintenance, right? Like communication integration. You don't have to worry about it. Your MCP client and your MCP server will handle it for you seamlessly. Okay, so if we understand the MCP here, the next topic I want to touch base on is one, like as a demo, is GitHub MCP Server, right? So I will share a bunch of MCP server examples at the end of the video for your reference. But in this video, we're going to demonstrate GitHub MCP Server to see how we can interact with our GitHub environment seamlessly without trying to interact with the GitHub API itself, right? I'm a big GitHub fan, and I do a lot of operations on GitHub. And when I want to do something with programming, like scripting, I need to use the GitHub API, which is a bit of a work to do that you need to know how to do it, how to automate it, where MCP will help us working with the GitHub environment seamlessly without touching the API itself. Okay, if you're ready, let's jump into the demo. Okay, so right now we're in a GitHub MCP server repository provided by GitHub. Shout out to GitHub for such a comprehensive repository. So here you can see, if I scroll down to the README file, it basically tells us the use cases such as automating GitHub workflow and processes, extracting and analyzing data from GitHub repositories, building AI-powered tools and applications that interact with GitHub's ecosystem. I think this is very necessary for cloud and especially DevOps folks who are very working with GitHub closely, they on daily basis. So in order to run this server in your local, what you need to do is there are some prerequisites. First of all, this server runs in Docker container. So you make sure you have Docker installed in your local. Once Docker is installed, make sure it is running. And lastly, you will need to create a GitHub PAT token, personal access token, that MCP server can use to interact with your GitHub environment space on behalf of you, right? So once you have those prerequisites, which I do right now, is basically installation part. Use it with the VS Code. Today I'm going to be using VS Code as an IDE platform. For a quick installation, you can either manually install from your user settings JSON, or what I'm going to do is I'm going to create a file called mcp.json in the .vs code folder in my workspace. Then I'm going to embed some code, some MCP server code, something like this, into my environment. Okay, so you can take this code, so if we jump into the IDE, what we have here is I do have my file. My code looks a bit different. I just updated a bit. So here we can see we have inputs as a type is prom string. ID is my GitHub token. Description is my GitHub personal access token, which is a password. Okay, this is my input to my MCP server, so it can take my PAT token and use it for the authentication purposes. Then we have servers code block, which is our MCP server. In here, we say GitHub, and command is Docker, which is going to be running in Docker containers. We have some arguments, run I, RME, and we do have the personal access token, which is getting the images from here. Okay, so all I need to do is right now you're supposed to see a start button here, which I do see running because my server is running. But what I can do is I can stop my server, and right now all you need to do is click on the start, and you're gonna see your server will be running. And if I go to outputs here, I can see my server is running with discovered 36 different tools. Okay, so we do have the GitHub MCP server installed in our local right now with 36 different tools attached to it. How to work with it is I basically open up my GitHub Copilot chat, which I'm going to use in agent mode, which is one of my favorite modes to use here. And here we do have a toolbox that we can see how many tools and which tools do we have in this GitHub Copilot. I do have 57. The reason is I do have other tools installed into my agent that I'm using on daily basis. But what I can do is let's jump into the GitHub README file again, the repository README file. That if we scroll down, we can see the tool configurations, right? So available tool sets that we do have is we can interact with repos, issues, users, pull requests, code security, and experiments. And you can basically use command line to select which tools that you want to do, or you can go with the old tool set which we already did. Okay, but you can select between the tools. And you have your dynamic tool discovery, which is in beta version right now. And you have your GitHub Enterprise Server configuration, which we will skip right now, and tools. So if you're a user right now, you do have your server. You can see there are commands that you can use to interact with those tools. So for example, get me basically gets the detail of authenticated user, which I'm going to be trying here in my agent. What I'm going to be doing is I'm going to just do get me, and we'll see how it works. Okay. So it basically says, hey, I need to call this tool to get the information of your user. And if I just expand this, I can see the details of this. And when I go and say continue, it basically runs that tool, and it basically gave me my user details, right? This is my GitHub profile, which is public, and it basically gave me all the details seamlessly. So let's jump back to the repository and try some other tools here. So I'm not going to touch on issues right now, but what I want to do is I want to show you guys my repository. Okay, so I do have a repository here which I'm going to be using, which is this one. Right now, we don't have any branches. We don't have any pull requests, this and that. It's an empty repository that for this demo. So what I'm going to be doing is, first, I want to list the pull request in this repository to see if it works, right? So what I'm going to do is I'm just going to do list pull request here. I'm expecting there's no pull request here. So I understand you want to do this. I need to bind some required parameters. Okay, so it's basically asking for the parameters, right? So what we can do is I can just give the command, and I'm just going to get my repository ID here, and I'll just give that to the agent. And right now it's going to run that tool to see if I expand it. You can see it basically found the owner, which is myself, and it's looking for the repo. These are the parameters of that tool. So it basically uses the GitHub API, right? But we're not touching the API itself. Just tool does it. But right now, I think it's having a problem, which I will need to. So if we do here, let's see. Okay, so here you can see it says I have looked at your repository, and it appears there are no currently open or closed pull requests in your repository, which is correct. So what I'm going to do is I'm going to jump into the README file. Okay, and what I'm going to do is from here, I want to create a file and open a pull request. But before that, I want to create a branch. So here, what I'm going to do is I'm going to search for a branch. So I want to use this create branch. So what I'm going to do is, by the way, if you do clear, it's going to clear your chat. What I want to do is create a branch called demo. Create a new file called test.txt and echo hello world in it. Okay, and here what I want to do is I want to find that tool, create or update a file here. Okay, and I give it and open a PR to from demo branch to, let's say, main branch. And I'm not going to give the tool set here to see if it's able to open a pull request without tool reference. So what I'm going to do is I just pressed enter. So it basically it will run the create branch tool, which you can see the details here. Okay, let it run. So it says I need a bit more information To proceed, I need to know username where you want to create the branch. Okay, so it needs the repo name. Then it needs the username. Let's give those informations. It's gonna create the branch. It's gonna try it one more time. Okay, right now it says it's created the branch. If I jump into my repo and check the branches, I do see the demo branch. Cool. Right now it's gonna create the file, which when I expand the tool, I can see the parameters, right? So it's running. So you can see the details of the tool. So it basically completed the step 2, which is created the file. If I go into my demo branch, I can see the test.txt file created. Now, right now, the last step that we requested was to create a pull request, which we didn't reference the tool name itself, so which is going to run itself, which is amazing actually. So I can see the details of the tool, and it says it created the pull request. If I go to the pull request, I can see the pull request is created from main to from demo to main branch here with our new creative file. So this is pretty awesome. We don't have to deal with the GitHub API directly. Server itself basically handles everything for us. And this is very simple example, but you can get very advanced utilizing server for your daily operations. They do have bunch of tools in here that you can utilize. All right, I think we're good with the demo. Okay, so after the demo, there are a couple of references that I want to share with you guys for the MCP servers. These are the resources I was just taking a look around, and I think these are most popular ones for now. One of them is the mcp.so, which you can see a bunch of MCP servers and the clients, different from GitHub to, I don't know, file systems, GitLab, Slack, PostgreSQL, right? Actually, this is like a repository, like a GitHub repository for all the APIs, all the agentic API calls, like something like that we can call it, which is pretty awesome. The next one is the MCP server directory, which you can check it out. The third one is one of the GitHub docs, which is the extending Copilot chat with the model context protocol, which you can check out and do whatever we have done in the GitHub Copilot chat. And the next one is coming from the model context protocol, which is the servers repository that has a bunch of different servers, from Git to Google Drive, Google Maps, and a bunch of other servers that you can utilize. Okay, so I'll make sure to put these resource links in the description. So make sure to check them out, and if you have any questions, you can just put in the comments below. And that's the magic of the MCP. If you enjoyed this breakdown and want to stay ahead in cloud, AI, and DevOps, make sure to hit that subscribe button, drop a like, comment below if you want a deeper dive into building your own MCP agents. Thanks for watching. I'm Khan again, and I'll see you in the next one.